Looking at the question 2, 5, and 6b from 7.1, your boss tells you that she knows the length of a widget your company makes is normally distributed with a mean of 25 inches and a population standard deviation of 12 inches. If you take a sample size of 9, find the mean and standard deviation of the sample, right? So the mean is going to be the same. The mean's not going to change. And this is ideally trying to get you to come to this conclusion. And in 7.2, they actually just flat out tell you that. The mean of a sample distribution is always equal to the mean of the population. Now, the standard deviation is actually calculated depending on the sample size. So we're given a standard deviation of 12, and so if we want to know the standard deviation of the sample, the standard deviation of the sample is going to be the standard deviation of the set divided the square root of the sample size. So in this case, 12 divided by the square root of 9, which is 12 over 3, which is 4, the standard deviation there. Number 5, so using the formulas for the mean and standard deviation of a discrete random variable, so this is given the formulas, you might want to put these in Excel or make it a column and calculate. Right? I can move this over a little bit. So and actually calculate x squared times p of x. So if I was to calculate each one of these, and you can see they've been calculated over here, 14.28, 14.82, 29.60, 22.54, so forth. This column is also just use a calculator, or you could use Excel very easily and plug that in. And it turns out if you sum the x times p column, that gives you your mean. In this case, 81.24, and then if you plug it in this formula and calculate the difference in the two columns, so this would actually be the difference, this minus this squared, and then you take the square root of that, you end up with 10.20. We get that, and then we get 81.24. So it's just applying these formulas. Number 6, so what you're doing here is you have 6 data points and you're taking 5 without replacement. So it lists out all the possible combinations, and really there's 6 choose 5, and if you plug that in your calculator, you see that that's going to be 6. 1, 2, 3, 4, 5, 6. To find the mean, 56 plus 52 plus 31 plus 26 plus 20 over 5. Mean of this one would be 56 plus 52 plus 31 plus 26 plus 15 over 5, and so forth, right? So it's just finding the mean of the 5 numbers. Write the sample distribution of x bar if x bar was 29.6. So I went ahead and calculated those 6 means, and it turns out 29.6 is a mean. And how many times does 29.6 happen? 1 out of 1, 2, 3, 4, 5, 6. So your answer here would be round to 3 decimal places, so 1.167. So the probability that your sample distribution is 29.6 is 0.167. So that 29.6 happens one time out of 6. And that's how you calculate that. If you have any other questions, please let me know.